Well, welcome and thank you for joining for this afternoon's virtual field day. We're thrilled to be highlighting a project funded by the Iowa Nutrient Research Center on modified blind inlets. I'm Liz Ripley, the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. We're based on campus at Iowa State University. Established in 2004, our goal is to build a culture of conservation, working with farmers, landowners, and researchers, much like those you'll see today, to implement conservation practices that improve water quality and soil health. All of this is made possible thanks to our partners. These include the Iowa Department of Agriculture and Land Stewardship, the USDA Natural Resources Conservation Service, Iowa State University Extension and Outreach, the Leopold Center for Sustainable Agriculture, Iowa Department of Natural Resources, US EPA Section 319, our Conservation Districts of Iowa, the Iowa Farm Bureau, Practical Farmers of Iowa, Growmark Inc., the Iowa Agricultural Water Alliance, Iowa Corn, and again, the Iowa Nutrient Research Center. So just some brief housekeeping before we dive in today. We've got a great in the field visit for you to learn about this innovative practice. But I ask that you just stay muted while the video is playing. But following the video, I'll invite my speakers today to unmute and participate in some questions and answers, in which case you can submit your questions either through the chat or you're welcome to unmute and ask your questions directly of our speakers today. So following today's virtual field day, you'll be getting an email. We ask that you let us know on that email how the virtual field day went. So please do fill that out. We appreciate your feedback on that. So without further ado, I'd like to introduce our presenters today. They include Matthew Streeter and Keith Schilling from IIHR Hydroscience and Engineering and the Iowa Geologic Service, Mike Postian, Scott County farmer, and Andy Craig with Ecosystem Services Exchange at Iowa State University. So again, at any time, you're welcome to submit your questions in the chat, but let's head on out to the field and learn about this great new practice being installed.
Hello, my name is Matthew Streeter. I am a soil scientist with the University of Iowa, and I am here today installing a new conservation practice called a modified blind inlet in Scott County. We are just north of Walcott, northeast of the big I-80 truck stop on Mike Postian's farm. And we have worked with Mike a lot in the past on conservation practices. He's an awesome landowner to work with, and we are excited to be working on this new practice. It's a modified blind inlet. So what we are doing is we are replacing a standard orange tile inlet intake. We're going to remove that intake, and we're going to put in essentially a French drain or a blind inlet where we can farm directly over that. We remove all of the anything that's going to be above ground surface. And we're also going to add a bioreactor into the bottom of this pit. So in a typical French drain situation where we're removing the tile inlet, it's just a hole that's full of rock, and it acts as a sediment filter for water to move through. We trap those sediments, and then we allow the water to move through the tile. In this case, below that rock, we have about a foot or a foot and a half of wood chips, and those are acting to denitrify as water moves into this system. So during a typical rain event where we get runoff that occurs, runoff is going to move over this modified blind inlet. We're still going to trap soils and sediments in this rock filter. We're going to be trapping phosphorus in that rock filter as well. And then as that wood chip gets saturated during a normal rain event, we start the denitrification process. So those anaerobic microbes start to work, and we start losing that nitrate before it goes out of the system. So we've worked on these modified blind inlets before. We had a previous study with the NRCS with a Conservation Innovation Grant, and during that study that happened from 2019 to 2021, we were able to measure about a 40% reduction in nitrate concentrations through the use of this practice, which is really great considering they're pretty cheap to install, and if we were putting these in for a farmer, they could go in just a couple of hours. What we weren't able to measure through that study was load reduction. So we didn't have flow actually moving through the tiles. We didn't have a good idea about how much water and how much surface runoff was actually happening. So what we're doing with this study specifically, and the reason that we're incorporating the AgriDrain boxes, is so that we can measure flow. We're going to have precipitation, so we'll have rain gauges. We'll know how much rain is happening. We'll know how much runoff we're getting. We'll know how much water is actually moving through this modified blind inlet, and we will be able to estimate total kilograms of nitrogen being removed from this practice. Now, the practice that we're installing right here is behind a typical graded terrace. It's a farmable terrace, but these can be installed behind wascobs or behind any other kind of a contour terrace structure, or really in any kind of a situation where you have a standing tile inlet. These things can be used. So in terms of installation, if a farmer were to install a modified blind inlet, it would be as easy as getting a backhoe, digging a small trench. We have the help to determine how large that trench needs to be compared to the watershed area. But it's as easy as digging a small trench where your standard tile inlet is, and then putting some perforated tile in the bottom and then backfilling that with wood chips and P-rock. Now for our study, it's a little bit more elaborate than that, because you can see that we have this AgriDrain control structure in the background, and you can see that we're starting to wrap up our installation. So we have that trench dug, we have the wood chips in the bottom, we have about half of the P-rock backfilled. Now the guys in the background now are finishing their calibrations on the radar sensor for the flow, and once they're finished with that, we can go ahead and finish topping off that trench full of P-rock. And I will say that as far as a lifespan is concerned, we have some of these that are up to a decade old now, and our recent study, our blind inlets from there are about 3 years old. We did have to top some of those off with a little bit of P-rock. We had a little bit of subsidence, but we're still seeing the same nitrate concentration reductions in that decades old site as we are in the site that's only 2 and 3 years old.
Hi, I'm Dr. Andy Craig. I'm here with Ecosystem Services Exchange and AgriDrain Corporation. We're installing a smart drainage system from AgriDrain here on a modified blind inlet, where the blind inlet is got a little bit of a hybrid feature that it has wood chips underneath the layer of P-rock, so it can treat and denitrify that water that's draining in from the surface. The purpose of this structure here is to monitor the water level in the structure and also the flow rate of the treated water leaving the structure. So researchers can get the nitrate concentration and the flow rate, and then use that to calculate the mass load rate and reductions from the practice. So this smart drainage system is on the cloud on agridrainsmartdrainagesystem.com, and the researchers will be able to access that data real time, download the data, and manipulate it that way for post-processing. It's a plug-and-play unit. We basically just put in the posts in the enclosure. It's already programmed. We use a radar level sensor to monitor the water level, and then set equations from the lab to calculate the flow rate when that water spills over the weir. So what we're looking at over here is a 2-chamber control structure with basically, that's the box sticking out of the ground. Water flows into it, has to build up a little bit and then flow over a weir, and that's where we calculate the flow rate. There's a radar sensor and a stilling tube that looks down at the water surface and very accurately and precisely tells us where that water level is. It allows us to calculate the head on the weir and the flow rate. And then the enclosure has a little programmable controller in it that does some math and algorithms and then sends data to the cloud to the Smart Drainage System website.
So the original modified blind inlet was referred to as an alternative tile intake, and this was this first project with the NRCS. And that team on that project was Thanos Papanucolo and Chris Wilson at the University of Iowa, as well as my counterpart, also my boss, the state geologist, Keith Schilling at the University of Iowa. And so Keith and myself and Thanos and Chris, we had this 3-year project to work on this, and we got these concentration estimates from these alternative tile intakes. I think that this spurred a lot of interest with the nutrient Research Center, and they had a call for proposals that specifically was asking for more information about these. And now in this call, they're referred to as modified blind inlets, so it's a little bit synonymous. So Thanos and Chris have moved on. Keith is still an active part of the process, not here today, but he is here as well. But there's still a new practice. We have 3 of these installed previously from the past project, and now we're adding 2 additional ones. So I think there's 5 of these that I know of in the state, and then after this 2-year project, we should be able to get this listed in the nutrient reduction strategy, and hopefully we'll see a lot more of them going in.
My name's Mike Postian, and I'm a 6th-generation farmer here in Scott County. Farm with my family. We raise hogs, corn, and soybeans, and we're in one of our fields today at an installation project for a blind tile inlet. So the reason we were interested in this project is I'm intrigued by the idea that we could treat the water in our field as it's going out our tile inlets, because that, you know, there's a concern there that we're bypassing a lot of the natural filtering ability in the soil and just sending it straight out the tile line. And so this is one way that we could potentially treat some of that water, but at the same time I'm intrigued by the idea that this could be something we could adopt on other fields and eliminate some of our tile risers and just farm right through those areas. So not only would we be able to treat the water going out of the field, but it actually might make our lives easier by not having to farm around standpipes, which can be a hassle sometimes. So we're excited to try this out and be able to have some monitoring equipment in place so that we know exactly what's going on, and that way when another farmer asks me about this and wants to know if it works, I'll be able to say definitely yes or definitely no. So that's why I like to partner with groups to do some studies in our fields, because you know, I have the same questions everybody else does, and if we can get some data to help us answer those questions and know what's effective and what's not, then I think that's going to help us be better stewards and make better decisions about what we do on our ground. I look at this as kind of an additional piece in what we're trying to do as far as protecting water quality, conserving soil, and things like that on our farm. So we've got a couple of saturated buffers in place, so that's kind of an edge of field practice that we're utilizing. And we've gotten to the point now where all of our acres are no-till with cover crops on there. So we're just trying to figure out what other things we can stack on top of each other to help us keep improving what we're doing as far as keeping our soil in place, keeping our nitrates, keeping our phosphorus in the field where it can be utilized by the crop, and just overall trying to be better stewards of what we're doing here on the farm. You know, from an energy efficiency standpoint, and you know, we've got a lot of hog facilities. Over the last several years, we've converted all of our hog facilities over to LED lighting. So that's kind of step one, is make sure we're reducing our energy usage as much as possible. But then in addition to that, then we've installed some solar panels on several of our sites. And the goal there is to, you know, number one, it makes economic sense for us. It's kind of a hedge on energy prices. My experience in my lifetime has been energy prices never go down, they only go up. So we look at this as a way to kind of lock in energy prices to some degree, but also then it's helping us reduce our carbon footprint. And that's something we're looking at. It's something consumers are telling us is important to them. And some of the companies we do business with are telling us it's important to them. And so we're starting to look at getting a handle on, you know, what exactly is our carbon footprint on our farm. And so we're working with a project that the National Pork Board is doing to actually take data from our farm and use that to actually figure out what the actual footprint is for what we're doing here on our farm. And so what we've seen so far is very encouraging, and I think that's going to be one way for us to kind of get a measurement of where we're at as a farm and what we might be able to do to get better. You know, we're always tweaking things and trying to do better. So, like, you know, you can't see it yet because this field just got seeded with cover crop last week, but I mean, I'm literally standing on our next project right now. We've been doing cover crops for probably 7 or 8 years, but we're still tweaking and still trying to get it right. So just in this field here, we have some trials going on. We've done a lot of cereal rye cover crops in the past. This year we've got some hairy vetch and crimson clover mixed in with some of that cereal rye on some fields. In this particular field, we've got another trial going where we're actually trying some winter camelina, which is a brassica, so it's something completely different. Just to try it and see if it works and how it compares with what we're used to, just to see what our other options might be. The hairy vetch and the crimson clover, we're trying to add some winter hardy legumes into the mix to maybe fix a little nitrogen for us to help the next crop out. So there's always something to tweak, and always, I mean, whether we're talking about soil and water conservation, whether we're talking about crop production, whether we're talking about our hogs, it's always about what can we do to get better every year. And so we're trying to do things every year to just make those incremental steps forward. And you know, what we're doing here today is just kind of another one of those incremental steps on our path to just improving what we're doing. So yeah, my kids would be the 7th generation to be on the farm. As far as, you know, whether or not they're going to want to be farmers someday, I can't say for sure yet, but you know, one of my biggest jobs is to make sure that the farm is in better shape if they want to farm than it was when I started. And so that's kind of in the back of my mind with all the decisions that we do. How can we make this farm better for future generations? So our oldest is actually a freshman at Iowa State in ag engineering, so you know, some of this stuff might be right up his alley, and if he has interest, then you know, hopefully I'll do a good job of making sure the farm's here for if him or either of my daughters are interested in farming. You know, that's what it's all about, just making things better for the next generation.
All right, so this is an image of final install after all the crew had left. So with my folks that are here to answer questions, feel free to join me by unmuting and turning on your video. And folks, if you have any questions for the group, feel free to submit those in the chat or simply unmute and ask them yourself. But with that, I'm going to stop sharing my screen and see what questions have come in. All right. So one of the first questions is, I'm going to direct this towards Matthew, but feel free to jump in if anyone wants to add as well. What was done to determine the size of the blind inlet? You mentioned that it was determined based on watershed size.
Yes, so in our first round of work that we did, Chris and Thanos at the time had done some modeling to look at the infiltration abilities of the pea rock and the wood chips, and so they developed an equation based off of watershed size and runoff to make these large enough for a 24-year 24-hour rain event. I think in this case, these were sized to drain a 5-inch rain event in less than 24 hours. And so for the two that we have installed, they're between 2 and 3 acres in size for the watershed. And we put in a trench that was 2 feet wide, 8 feet long to the depth of the tile, approximately 4 feet. And that came out to draining that 5-year event in somewhere around 12 hours. So well underneath our 24-hour kind of limit for when that had to be drained by. So that work was all done before. We actually have a note that has been published with that first round of study to guide people on how to build these things, and that's part of it. So you can figure out you know, your soil types and then use the equation, and it'll tell you how large of a trench you actually need to dig.
And it looks like maybe Gary, did you have a question you wanted to ask? maybe not. Maybe he's still thinking about it. All right. So a question here, since this is primarily surface water treatment, it sounds like there will be a lot of time where the wood chips will dry out. Does the cycle of wet dry cause concern for quick deterioration of the wood and production of methyl mercury? So I'll defer that again to Matthew and or Keith there.
So I honestly can't speak to the methyl mercury. It's kind of out of my wheelhouse, but it certainly was a criticism that we got before, because these are going to dry out often, that they may deteriorate. There is that original alternative tile intake site near Amana, and it's over 10 years old now, and it is still functioning. It's still denitrifying. So we know that those wood chips have not been completely removed, over that length of a time period. And then what was the other part of that question?
The quick deterioration of the wood and the production of methyl mercury. So estimated length of how long you think these wood chips would last.
Yeah, I was going to add that another criticism about the saturation versus not saturation was in these smaller rain events, when you have surface water runoff, is there enough time to actually saturate these wood chips to get denitrification to happen? And during that first study that we did, we had several about 1/4-inch rain events that did not produce a lot of runoff, and we were still getting that same denitrification happening in that system. So it seems like those bugs can turn on really quickly, and it appears that it's lasting, at least for a decade.
Andy, did
I
you
was
want
just going
to
to
add
add to that, Liz, real quick, if I could. The methyl mercury wouldn't be an issue because you're draining vertically through these wood chips pretty quickly. So with the low hydraulic residence time, methyl mercury production wouldn't be an issue like it would in a where it could stagnate in a traditional bioreactor. It's a little different.
Excellent. So speaking of those wood chips, will there be a need to replace them like we've seen with classic bioreactors? And if yes, how long do you think those wood chips would last? What's your estimated lifetime on those?
Well, it's hard to say what the lifetime is going to be. I think that the original thought was that these things would last a decade. And again, with that original site that we have near Amana, we've seen that they've lasted at least that long. It's really hard for me to give a time frame on how long these things will last. But I will say that after the wood chips stop working, it still should be an effective sediment trap. And an effective, blind inlet for a lot of time to come. There's no foreseeable end to that. And I don't think that it's really possible to just dig it up and replace the wood chips and put the old rock back in. At that point, I think if you're looking at a decade, 15 years, you're probably going to remove the old, muddy and plugged up rock and just start over from scratch. So you would dig the thing up, put in brand new wood chips, put in brand new rock. But all indication is it's going to last at least 10 years.
So maybe Matthew, this one goes to you too, but feel free to punt if need be. But what kind of phosphorus reduction was reported with the traditional blind inlet?
Keith, you might have to help me with this because I don't have the numbers right off the top, but I know that the phosphorus reduction was not as high as we had expected. Keith, can you pull some of those numbers off the top of your head?
I really can't. I could look at my other screen and let you just flounder for a while, though.
Yeah, I'll just flounder for a while. I know that if we were looking at the blind inlet independently, the phosphorus reduction was not as high as we had expected. But if we considered the whole practice, the whole set of stack practices, so including the terrace, where we're obviously trapping a lot of sediment, there was a fairly significant amount of phosphorus that was being trapped by that whole system. But the dissolved phosphorus was not that high. And that, of course, is something that we are really interested in measuring again with this study. So we're gonna be taking event-based samples during any event where we're getting flow, and we will take ISCO grab samples throughout the period of a rain event, and we're going to analyze those for total phosphorus and orthophosphorus. And so we should have a pretty good idea about what's happening with phosphorus after this second round. Any luck, Keith? No, I'm sorry.
There's a lot of stuff in the file, so
Yeah, no,
this goes on. I'm getting closer.
That's okay.
Well, while you're still looking for that, there's a question in here, and I had this one too. What was the total cost for the installation for one site, and are there or will there be dollars available for this practice?
So if we split up the installation between the cost of the sensor and the cost of just what a modified blind inlet would be, the sensor itself that's going to allow us to measure flow and the aggredrain control structure was about $7,000. The remaining cost of the installation, which included hiring a backhoe operator and buying some rock and wood chips, was only about $500. So in a real world situation where we're obviously not going to need that aggredrain control structure or any of the sensors, this is about a 3-hour job for a backhoe operator. It's about $300 and maybe $150 or $200 for the rock and the wood chips, depending on the size of the trench. So this is a $500 and 3-hour operation to get these installed. So when it comes to conservation practices, very inexpensive and very quick.
So quick update on the phosphorus reduction. So we did see at the other project have a 15% reduction in total P and a 9 to 10% reduction in orthophosphorus. So I think the monitoring that's been set up with Matthew and Mike and everybody is head and shoulders above where we were last time. So I anticipate with better monitoring, we'll probably kind of narrow the window of performance down a little bit than what we saw here. These were, we learned a lot of lessons, as you always do with project 1 versus project 2. So we've seriously upgraded the level of monitoring here and fully anticipate great results coming from this.
Thanks, Keith. I know we were chatting a little bit before folks got in, but Mike, you were commenting on the cost of a single standpipe.
Yeah, I mean, you can't even replace a standpipe for under $100 anymore. So yeah, really, I don't think cost is not going to be an issue. I think it's going to more be somebody with a backhoe who's willing to come out and putz around in your field and do some of this. But a lot of folks have their own backhoes anymore, and I think we'll see how this goes. But if it's something that we like, we'd look to kind of try to put these in batches at a time and replace quite a few, so you could maybe turn it into a couple days work to get a bunch of these done. And I think the last question was asking about if there's like cost share available, things like that. And I think probably not right now until it gets on the list as an approved, which might be available for cost share. Does somebody want to correct me on that?
And I think that's been the process for other practices like saturated buffers and oxbows and things like that. And Matt's hopping on with INRC. He can clarify that too.
Yeah, I was just going to say that the alternative intake with just gravel and sand or gravel and P-rock is a practice listed on the Iowa nutrient reduction strategy, kind of that menu of practice list that's been added since the release of the science assessment 10 years ago. So that's there, and this this would be kind of an addition. So we're excited to see what the performance is if we can get kind of dual nutrient strategy with this.
Thank you, Dr. Helmers. All right, so this question is asking kind of logistics in the field. So obviously you've got all that monitoring equipment out there, but for the standard design, can implements and tractors drive right over it, plant over it, and they're curious how the soil infiltration, how is soil infiltration sufficient in this infiltration zone?
Yes, in a real world environment where we're not trying to monitor anything, there's going to be no structure, there's going to be no inlet, nothing like that. It's just going to be P-rock. And you can probably see from that final picture, maybe that P-rock's a little proud when we left it, because I had mentioned that we did get a little bit of settling over that first couple of years. But as you take a couple of trips over that with the implements, those are going to level out. And then over the course of a few years, you are going to get sediment that is moving in over the top of these inlets. Now, one thing that I neglected to mention when we were talking about how we size these, part of that sizing equation had anticipated 6 inches of sediment over the top of this inlet, and it's still going to drain that 5-inch rain event with 6 inches of sediment in that 12-hour period. So we're anticipating that there is going to be sediment that's moving over the top of here, but you're going to farm right over it, and there's not going to be any kind of other restrictions. So that's a especially great thing when it comes to a graded farmable terrace like Mike has, because there's literally not going to be any obstacles in the field left at all. And then if it were to a point, if we were in a field where there was tillage and you were getting an exceptional amount of sediment moving over the top of this, and you thought that it was starting to affect how that was filtering, I think you would take your skid loader or a backhoe or something like that and go and pull that sediment back off of the top, just like you would pull sediment away from a tile intake if that became a big problem. But, in a field like Mike's, like what was in the video where we've got no-till and cover crops, I don't think that, sediment plugging is going to be an issue for a very, very long time, if ever.
Coming back to that cost share question, someone mentioned that NRCS does currently cost share blind inlets, but only in conjunction with another practice like a terrace. So that's definitely a question to take into your local NRCS office. I've had a couple folks here asking if they can get a copy of the design note. So I'm not sure if that's ready to share quite yet, but I can share in the chat here the grant summary from the Iowa Nutrient Research Center, so you can take a look at that proposal and a little bit more, read more in depth about what they're looking at.
Yeah, Keith might have to disagree with me here. I don't know if this is right or wrong, but these reports and these design things are all public and submitted to the NRCS, so I don't see why those shouldn't be publicly available, right, Keith?
Right. Yep. They should be part of the record. Now, they were submitted to NRCS, and I'm not sure how their process works, but I guess until we post it completely, just reach out to Matthew or myself, and we'll send you what we have.
And I will say that I do anticipate making a version 2 of that with with adding in a couple of these lessons that we learned even through this installation process. But yeah, absolutely reach out and I'll let you know what I know. But I would assume that there'll be some kind of a technical note or something like that that'll come out eventually with guidance on installation.
So there's a couple of questions here. Will future research incorporate phosphorus sorption materials? And then another one that's asking about mixing in carbon media for nitrogen removal.
So I have seen some work come out of Iowa State that was looking at phosphorus sorption using like recycled metal materials in those rock filters and things like that. And I mean, it's certainly something that somebody could look into, but right now we've got 2 years to learn about N and P and what these things are doing with just the wood chips. So I'm going to focus on that for right now, and I guess we'll see what the future holds.
Okay, so here's a question. Assuming you retrofitted a traditional surface inlet on a terrace with a blind inlet, how do you design the capacity of the blind inlet compared to the need of the outlet capacity for the storage section of the terrace? That's a big question. I'll read it again.
Okay.
So they're retrofitting a traditional surface inlet, much like you were doing at Mike's, with a blind inlet. How do you redesign the capacity of the blind inlet compared to the needed outlet capacity for the storage section of the terrace?
I think if I'm understanding correctly, this is all just based on the trench size. So if you have a certain storage capacity, those storage capacities for the terraces are based off of these same types of rain events and how big of a rain event is going to be able to be stored behind that terrace. And we are looking at those same, size of rain events and just literally making the trench bigger or smaller. So if instead of a 3 hectare or acre watershed, we had a 6 acre watershed, we would, double the size of that trench, and then you're going to get more infiltration. So it's literally just modifying how big of a trench you're gonna cut in. And I can't really think of a too big is a problem, other than the fact that if you don't get those wood chips saturated, you might not be getting the denitrification. So yeah, I don't think that you would want to just put in a huge hole all the time. You probably want them somewhat appropriately sized so that you're making sure that that denitrification is going to happen. I hope that answers the question.
And just basically matching the drainage needs with the size. So you're controlling that. Your limiting factor is the pea gravel patch, right? So depending on what the standard would say for if it's a 5-year, 24-hour rainfall that you need to match, and appropriately size that. And then also with some safety factor for some plugging down the road. I think a 20-acre contributed area could be a blind inlet size of like maybe 50 by 50 feet. So it gets pretty intrusive if you're draining very large areas, but typically a small terrace like that wouldn't be a catchment for a 20-acre section of the field. So it's just matching what you need to drain with the media, basically.
And if you could repeat, Matthew, if you remember from the video or from your data, the reduction of NNP you experienced at your 3 previous sites.
So we did concentration reductions, and we got an average concentration reduction of 40% for the nitrates. And I think Keith just said that it was between 10 and 15% for phosphorus, correct?
Correct. One thing of interesting note is usually you think of surface runoff as having low nitrate. Those fields, Matthew can elaborate some more. The concentrations in the runoff of the previous ATI project were very high. It was a manured field. So the concentration reductions were really from like over 30 milligrams per liter of the inflow water to the ATI, and 17 out or something like that. So those concentrations were really much higher than you might expect, especially in a manured field like this. Matthew probably could weigh in some more, but I was just looking at the data.
So it was pretty interesting because I know one of the landowners fairly well from the first project, and he's surface applying hog manure, but he's got his terraces. It's a fairly flat field, and he's got a rye cover crop. Every fall he's putting out rye, and it's a nice looking stand of rye. I've got some pictures of just this beautiful, 1.5-foot tall rye in the spring. And he said, I really don't think you're going to have much luck here. You're not going to have any problems because I've got this rye and I'm just doing a great job of management. And I said, well, we'll see. And that first rain event that came along that spring, we were pulling, I think, 54 milligrams per liter nitrate off the surface runoff, from that field. So he was just absolutely shocked that he was getting that much runoff, because he just knew that rye was taking all that up. So clearly, there's a lot moving around on the surface as well.
So an argument for combination of practices working together to meet our water quality goals. So I'm going to kind of pass this one to Mike a little bit, but also feel free to chime in. So was anything placed on top of the pea gravel, and if the management monitoring equipment wasn't there, how would tillage or running your planter through it impact your decision of management in that field?
Yeah, so that's one of the most intriguing things about this project to me, is if we can just dispense with any kind of riser on the surface for the trial drain, because those are inherently a pain to work around at times, and our combine seems to have developed a taste for the standpipes. They kind of sneak up on you when the corn's twice as tall as they are. But we don't obviously, with this current installation, we've got to work around the monitoring equipment, but I would anticipate that if we just had an install, just the blind inlet itself and no monitoring equipment, that we would most likely just leave our planter in the ground as we drove through it. The pea gravel is not going to hurt any of the equipment on the planter, and we'd probably just I don't even know if we'd bother programming that in to not drop seed there, because it really wouldn't be much seed that would get planted in a relatively small area. So we just that's not an issue. If we did, we'd obviously want to work around that, not intentionally drag anything through it from a tillage standpoint, but not that it would hurt that so much, but it would probably just accelerate how fast it silted in with dirt. So we're really, I'm hoping this will be pretty hassle-free to farm around.
All right, so this is a logistic technical question here, but how big was the footprint of this particular blind inlet that we saw in the video?
So the blind inlet itself is 8 feet by 2 feet and a 2 tile depth, which is 4 or a little more feet deep. And then we have a couple of extra feet that's being taken up because of our monitoring, but this is a 8 foot by 2 foot trench.
So you mentioned in the video that the goal is to get an approved practice. How much more research and testing do you think you'll need to feel comfortable getting an approved practice, and timeline for how long that could take?
Well, that's probably a really good question for Keith. The big goal with this study is to be able to measure load reductions. And I think that's going to be, obviously essential component to this, but as far as timing and everything, that might be a better question for Keith.
Yeah, it took, we got the multi-purpose ox bows listed. It was definitely a several year process with additional years just needed to put load reductions and error bars on the load reductions. So it's not a one-off kind of thing where you got 1 year and that's what you put. You need to have multiple years so you can set some idea of the range of performance. And I'm going to defer it to Matt. He maybe has some even bigger picture versions of this.
Yeah, not sure I have too many bigger picture to add on to that. I think, one of the things too might be thinking about, especially if it was something that NRCS would cost share, thinking about developing a interim standard for these interim conservation practice standard. Maybe something to think about as well, or how it might be added on to any existing standard that you might have augment for adding the wood chips. So that'd be another aspect that I think moving forward might need to think about as we think about cost share.
So this one kind of ties into that because of the nutrient reduction strategy, but this person noted that for places in Iowa where terraces and wascobs dominate the landscape, these could be good alternatives for bioreactors and saturated buffers, which tend to be more in our tile drainage systems that are flat. How have you estimated how retrofits could impact water quality to contribute to meeting the nutrient reduction strategy? I know your goal is to eventually get it added to this, but maybe that's tied into that previous question as well. No, I'll jump on it at once.
Again, I absolutely should have had my my estimates from our previous work, because we did make some load estimates. Keith, you still have that pulled up? Because we made some estimates for another watershed to give us an idea about potential percent reduction for that watershed using that practice. And I apologize because I did not have that brought up.
Well, maybe while you're
Well,
looking for that.
one thing I could add one thing while they're looking
Yeah.
there, in some cases, location for various reasons, locations are not suitable for edge of field practices. If for a saturated buffer, you need to have a stream with an appropriate bank that you're not going to create new problems there. And so it may not be an option to have a saturated buffer in, but maybe this is something would be an alternative available, depending on how the landscape looks in the area around the field. So it in some cases could be your only option if some of these other practices don't fit.
So I did find what I was looking for here, and even though we didn't have load reductions, we did make some estimates for this watershed called Old Man's Creek watershed, kind of southwest of Iowa City, based on some stream data and using using some other watershed tools. And this watershed area is about 64,000 hectares, and we estimated a end-load reduction of 1.6% for the total watershed using this practice. Again, that's not real data necessarily, but that was a kind of our back of the envelope estimate of what this might be doing for that entire watershed in a similar landform region of where we're working now.
Yeah, that was assuming all terraces were retrofitted with this practice.
Yes, exactly. So if we put this practice behind every single wascob and behind every single contour terrace in that watershed, we would get a 1.6 reduction.
Do you know about how many, what the total number of inlets it would have been? It was hundreds or something, right?
I don't know the number of inlets because, of course, there's different numbers of inlets behind terraces. But what I do know is that the catchment area for those BMPs was only about 4,000 hectares compared to the 64,000 hectares for the watershed area. So this is still, influencing a relatively small amount of area in the watershed for that 1.6%.
I realize.
Sorry, Liz, one more thing just for, I meant to ask it earlier when we talked about the design and the size, but Matthew, do you recall the sort of the contributing catchment area for the two that we installed, Walcott and Kyoto there?
They're between 2 and 3 acres, I believe. Yeah. So
Small.
relatively small catchments.
And for those that may not be familiar with that term WASCOB that we've been throwing around a little bit, that's the water and sediment control basins. So you may hear them called one of those two phrases. All right, so if you've got questions, feel free to get those in there, but I know a few of you likely attended today's virtual field day to get a CCA credit. So I'm gonna share that information now. So if you did watch this live for CEA credits, feel free to send me an email. I'll put my email in the chat as well by 5 p.m. today, and I will get your credit submitted on your behalf. If you are interested in an edge of field practice that is already got a design standard like a wetland oxbow bioreactor or saturated buffer, again, feel free to email me with your contact information, and I'll help connect you with folks at our Iowa Department of Ag and Land Stewardship to see if your site is suitable. And we are receiving some USDA funded funding. So we ask that if you attended today, be willing to participate in filling out this voluntary survey. You only need to do it once for all of our virtual field days and webinars. So thank you. And if you can, I encourage you to join us on February 9th. It'll be our next virtual field day, another project funded by the Iowa Nutrient Research Center, where we're looking at beavers. Are they superheroes for water quality? So tune in to check that out and see what those ecosystem engineers are doing out on the landscape. All right. So I don't see any more questions in the chat, but if anyone has any final questions they'd like to ask, feel free to do so. But I will turn things over to Matthew, Keith, Mike, or Craig, Andy, excuse me, if you want to give any last words on what we're learning about today.
Well, I don't have a whole lot more to add right now about the modified blind inlets themselves, but I would like to say thank you to everybody for joining today. I noticed, I think, 103 participants at one point, which I thought was fantastic. I'm really excited that there are as many people excited about it as that, and I'm really looking forward to the next couple of years to see what we see when it comes to rain. Believe me, when March comes around and the rain comes, we'll be out there and be very excited to catch that, and looking forward to hopefully provide an update here in a year or so about what we found.
Yes, we'd love to have you back after you get some data to maybe do a webinar. Give us an update on what's going on out there at those sites. Again, thank you all so much. Again, this is being recorded, so if you know someone that missed out on attending it live, that email that'll come with the evaluation this afternoon will contain that link, so feel free to share that, and we'll see you all next month. Take care.